we'll start the session. Okay, so how are you all? In the last session, last week, we have discussed on APB protocol, right? Advanced Peripheral Bus Protocol. So one protocol is completed in AMBA. So do you have any doubts in that?
Yes, ma'am. When we move from setup to access state,
Mm.
we in the code there is no P enable.
Mm. Okay.
Ma'am,
So
can you
I have
open the
shown
code?
you I have shown two different codes to you with enable, without enable also. Have you checked those?
Yes, ma'am. You sent to one. Which one is master slave?
Mm.
Another one is slave and SB master.
Okay, so have you not tried with putting the enable there? In that code, there is no enable. Okay, fine.
Yes,
So
ma'am. I
you need
tried.
to try, right? So did you try what output you got?
Ma'am, I will send you in WhatsApp.
Hmm?
I will send you in WhatsApp. I tried in Vivado with
Okay.
Verilog
So
test
is it
bench.
getting or not? Is that working or not?
Yes, ma'am. Can you check?
Okay. You can send me that code
Okay.
afterwards. Okay. You need
Okay.
to clear these doubts within weekdays. What you are doing in weekdays, you need to send in the group, right? So that remaining people also will check what's the error is getting. So they will also try with
I,
whatever others getting some doubts, everyone will try,
ma'am,
right?
I sending in WhatsApp.
Send
Can I
in the
send
group.
WhatsApp group?
Yes.
WhatsApp. Yes.
Okay. So any other doubts from APB protocol? So can you tell me what are the features of APB protocol and what are the limitations with APB? Hmm? Venkatesh, Shweta, Ashwini, Srija, Ranjit, Gopinath,
Um,
Roshini.
Like it is used for a low power
Low
and no
power.
pipeline and no
Okay.
pipeline.
Okay.
Write and read is dependent.
Hmm?
Write and read is dependent.
Okay.
It won't have separate chance for write and read. Okay?
Hmm. Have you gone through the specification? Spec. I shared the spec also.
Yes. Yes.
Okay. So do you have any doubts from the spec?
No.
Okay. So APB protocol is a low speed bus protocol. It's just a simple control bus, right? It's a very simple where we connect with the low peripheral devices or low speed peripherals like you ought some timer, watchdog timer like that. And APB protocol doesn't support the pipeline. In the last session, I have explained what is mean by pipeline. Pipeline in the sense parallelly, we can do the all type of operations like fetching, decode, execution. In terms of APB or AHB, if we speak, multiple transfers we can initiate parallelly. Okay. In APB protocol, we need to wait one transfer is completed, then second transfer will start. Once the second transfer is completed, then third transfer will start. Okay, so that is serially happening, but pipeline means parallel. Okay, within the stages we can increase the speed of operation in a pipeline architecture. Okay, so but APB protocol doesn't support the pipeline. And what are the limitations, like it doesn't support burst transfers, because what is the burst transfer in the sense, I will explain in the AHB protocol, where we transfer the data in terms of beats or multiple transfers at a time. But in APB protocol, we are sending only piece of data, in the sense 8-bit data or 16-bit data, like that we are transferring. But in AHP protocol or AXI, we can transfer the data in terms of burst, that means multiple transfers at a time. Okay, so coming to the applications wise, I already told for low speed peripherals, and APB protocol have very few signals. That means simple address, enable, write, select, very simple signals will be there. And it is always useful for lower peripherals. Okay, so coming to the AXI AHB protocol. Today we will start with AHB. AHB means Advanced High Performance Bus Protocol. Okay, so it is a high speed, high performance system bus. Comparatively with APB, AHB is high speed. Okay, comparatively with AXI, AHB is low speed, but with APB, AHB is high speed. Okay, it's somewhat complex programming, not like AXI. It have few complex signals, more number of signals comparatively APB. Okay, so it's just somewhat complex protocol only, and that too AHB protocol support pipeline, and also it have good features, like we are not discussing AHB Lite. AHB Lite means very simple, just one master, one slave. We don't connect multiple masters and slaves. But AHB protocol, we have multiple features, different features like burst transfers, split response, retry. There are different features. We will discuss everything clearly. Okay. And in terms of speed transfer, how much data speed it will be transferred? Mostly it supports the pipeline operations, right? High speed data transfer, it will support in terms of gigahertz. And also it support the different transfers like burst transfers. We will discuss that. And it supports the multiple masters, pipeline architecture, and also and also it have the different phases: address phase, data phase. Okay, in APB protocol we don't have the phases. Okay, what signals we have? Just a clock, reset, select signal, enable signal, and separately p address, p write data, p read data, like that we have no separate phases. But in AHB we have the separate address, and data phases can overlap, they can overlap. But in APB protocol, address and data phases happen sequentially, they can't overlap. That means once address is select or address is sent, once it is completed, then data signal will active. Okay, like that write read operation also same, both cannot be done at a time, one after another, right? So in AHP protocol, it operates at a high frequency, mostly used for CPU to memory applications and CPU to high speed peripherals. If you want to if you want to connect a RAM or any cache memories or DMA controller, mostly we use AHP protocol for these type of applications. Okay, and coming to the signals wise, in APB protocol, we represented with the P ready signal, P clock, P enable, P reset, P address, P data, like that. In AHP protocol, all signals will represent with a H clock, H reset, H burst, H ready, H transaction, H size, H response. like that. Okay, so that is one of the signal difference. And power consumption will be more only as per because if you see here the block diagram in APB protocol we don't have this type of block diagram, right? So whenever the complexity of circuit is increasing, automatically power consumption will also increase, right? And next, coming to the AHV protocol features, if you see here, burst transfer. Burst transfer means it's a sequential transfers where we can transfer multiple data at a time, not like a small piece of bits. Okay, we will discuss that clearly. There are a lot of sub classification on burst transfer. Next, split transactions in the sense where we allowing the slaves to stall the transactions and retry them later. Okay, so whenever it is in busy state, the slave is in busy state, we are just making as um, a constant. Okay, so split transactions we call. And wider bus data bus configuration, because AHB protocol will work till 180-bit data, okay, 256-bit data also. But in APB protocol, we can access till 32-bit only. Okay, so wider data bus configuration and a single clock edge operation means all activities, whatever we do, the transactions, everything occurs on the edge of the clock, rising edge of the clock. So that is single clock edge. And a single cycle bus master. Single cycle bus master in the sense same like a clock edge, within single cycle we can access the master and it have the pipeline operations to improve the throughput. Okay, so these are the features. See, most of you, I'm just getting the queries like, most of you not able to understand like what protocol we need to, within the protocol, what, please mute, within the protocol, what we need to focus mainly. Okay, so I think you got the clarity from before protocols like a UART, I2C, APB. We discussed very clearly functionality wise and how to design and how to verify. That is perfectly okay for interview point of view. Okay, but still we don't know some of the interviewers, they based on their mindset, not only mindset at the time, sometimes there will be it totally their mood swings. Okay, so depending on that also we will get the questions. Okay, if there are in a happy state, okay, they will ask a few easy questions and it's go on like that. Okay, but sometimes we will get very difficult questions also which are not irrelevant with the protocol. Okay, so whatever we are discussing here, that will be okay, perfect. But if you have time, if you want to concentrate more into the deeper, whatever the specification is given, you can follow that. And for APB protocol also, I have given the interview questions. Mostly if you want to concentrate in UVM and system Verilog coding wise, I have given the interview questions. Like that, you can practice some more practical approach. Okay, so that will be okay. That will be 100% okay. Okay, so that's what. Next, coming to the, these are the features we will discuss one by one clearly. And coming to the architecture of AHB, tell.
Hi, ma'am. So Akhil this end. So I have doubt, like so now if I SOC have both with the APB, AXI and AHB. So all this conversion, do we need to use a separate bridge? How the means in every time if you are working, there will be a bridge associated with every protocol. If I want to convert AXI to APB, there will be a bridge, or AXI to AHB, there will be another bridge. So everywhere it will be like that. There is a common bridge module which will be converting this AXI to corresponding lower and low power or lower end protocols.
Mm. Yes.
That is my query. Means if I'm purchasing an IP which having an APB or AHP interface, this bridge I need to do separately, or all the interfaces will come along with the bridge.
Uh, that depends on when we buy the IP. It totally depends on how we are buying. Sometimes we can buy with respect to bridge, okay, and sometimes alone. That totally depends on our designers how they want to prefer. They want to prefer with a bridge or without bridge.
Okay.
Yeah.
Means when we have filings IP, they will, when we will configuring that IP, they will ask, right, AXI, APB, or while configuring which protocol is the interface protocol. So that
Hmm.
means the bridge will be inside this IP, correct?
Yes, bridge will be connected not inside the IP. Between two IPs, the bridge will be connected. The lower side, suppose APB protocol is there. APB protocol will be connected to the lower side IP. APB to bridge will be connected. APB will be inside the IP.
Okay.
APB to IP will be connected. Let me draw. here there is some memory or whatever IP. So here there is a interconnect, and here there are multiple IP blocks, IP1, IP2, IP3, IP4, like this. And here inside the processor there are multiple number of cores or cache memories. The interconnect, this is what AXI. And here these IPs are connected to the APB. So with the IPs, APB will be connected, with the high speed AXI will be connected. In middle we use some bridge connection. Bridge is nothing but some functionality, just some like bus functionality. It's a hardware. We use the finest admission. Tomorrow we will discuss about AHB to APB bridge, how to design. So it will connect just like this signals, these signals and these signals will be connected. It's a block here.
Okay.
Okay. So next, so this is what AHB protocol block diagram. Okay, so we can have multiple masters, multiple slaves, but if you go with the AHB Lite, we have only single master, single slave, but we don't use the Lite here. So we are using AHB master, AHB protocol. So master means what? Whatever the protocol it is, a master means initiating the transfers, whether it's a read operation or a write operation, it initiate the transfer. Slave will respond to the master operations. And in AHB protocol, we have the arbiter concept also. In I2C protocol, we have used the arbitration concept, right, to select the master. So if there are multiple number of masters, which master need to initiate the transfer? Like that, we used arbitration concept there. In the same way, AHB protocol having multiple master, multiple slaves. So we need to use the arbitration concept here, so that arbiter will grant the access to one master at a time. One master, and it will select the slave according to the address. Okay. And if you see here the decoder logic, decoder in the sense it select which slave should respond to the address provided by the master. So H select 1, H select 2, H select 3. Three H selects are there, so 3 slaves are connected here, and the decoder is getting the another signal. Here multiplexer selector signal is getting from the decoder. Okay, so multiple masters and multiple slaves can exist here, but only one master can use the bus at a time. Okay, and H write data, H read data directly, H address directly will be connected to the selector, but based on which selector, that will be dependent on the H decoder. So whatever the H select is giving some read data, that will be sent to through the multiplexer. Any one data will be sent to the master. Okay, because one-to-one connection, right? So one data should be sent to the master. Okay, so this is what overall AHB master and slave block diagram. One master, 3 slave. So based on this, we have the signals. H clock, nothing but bus clock, reset. You already know what is the use of reset. It's actual or reset. Reset n means like that. Address signal, here there is a address signal, 32-bit address, write data, read data bus, and H trans here. H trans in the sensor. In AHB protocol, we have the different types of transfers. Okay, transfers in the sense whether it should be ideal state or busy state or non-sequence, sequence, like that. We have different types of transfers. We will discuss that thing. Okay, and H write. H write means same as a APB protocol. In APB protocol, we have H write, right, to select whether write data operation or read operation. For that purpose, H write we have. And next,
What does
H.
the H represent? Sorry.
What?
What does the H represent here?
H means AHB. H. Just
Okay.
it represents AHB.
Like
APB
in
protocol,
APB, P.
P we written, right?
Okay.
P address, P clock,
Mhm.
set. In the same way, here H means AHB representation, like that.
Okay.
But here we have few signals, so we are representing AHB as a H. But if you go to AXI protocol, there we don't have like these few signals like that. We have channels, different channels, write channel, read channel, response channel. Based on the channels, we have the separate names. For suppose write address, write data, read data. According to that, we will have the values AW data or B response like that, okay, based on the channels. But only in APB protocol, AHB protocol, it will represent with the P and H.
Okay. Thank you.
Next,
Hello.
yeah, tell.
Hi, ma'am. So one more doubt. The bit width you mentioned, it is a maximum. Means if H address will be maximum of 32, H data will be maximum of 32, H size will be maximum of 3 bits, H burst will be maximum of 3 bits. Is it a maximum value, or how we will know what is the maximum supported?
Maximum it will support till 128-bit data.
Means H data, HR data or HW data can be 128 bits.
Yes, yes.
Remaining, it's like a 32 bits and 3 bits. Remaining H burst and will be maximum of 3 bits.
H burst will be changing. H size, it totally depends on how you are taking the address and the data. Those also changeable, but H trans will not change, and H protect will not change. There are a few indications like H trans means only 4 transactions it indicate. H size will be changed. H burst also can change.
Means if it is a 3 bit, like two 8 combinations will be possible, correct?
Yes.
So that means that's what I'm asking. Maximum bit, maximum bit width will be 3 bits. In that we can select the configuration.
Yes.
Okay.
So these all variable.
Ma'am, how handshaking mechanism works in AHP?
I'll wait. We'll discuss. Okay, so that is what. So address will be changeable up to 4 GB to power 32 bits or 128 till then we can use. Okay, so H size will be also same. Okay, and next coming to the H address. H ready and H ready in the sense you already know wait signal. So a slave ready signal just indicates the slave is ready for the next transfer or not. Next, H read data. H read data means just read data bus, and H response. It responds from slave. OK response or error response or retry response or split response. In APB protocol, we have slave error, right? It just indicate whether error is getting or not, slave error. Here we have some more advanced level like the slave indicate OK. OK response means if it is receiving the correct data, it will send as a OK. If it is sending as error, error response, retry and split. We will discuss what is meant by retry. Retry is nothing but again we need to send split in the sense we just making it as a constant so that the master will initiate the transfer again. And next H master lock. H master lock means whenever one master is in busy state, remaining all masters will go to the lock state. So that is what H master lock. And H size means the size of the transfer, whether it's a byte or half word or word size. Based on that, H write will be indicated. And That's it, right? Protect signal. Protect signal means you already know in APB protocol we have seen the privilege access, data access, instruction access like that.
Hello.
Just left side, yeah, tell.
Ma'am, can you briefly explain that how that if you have like a 32-bit data, how that it says the word, the byte, how it means, how it will be splitted?
See, in some AHP implementations, 64-bit, 128-bit extensions will be possible. That means it will take the sizes. Suppose it is a 64-bit size, then the size will be 8-bit here. H size will be 8-bit. Then what about the burst length in the sense? Um, we have the burst length like wrap 16, wrap 32, wrap 64. Based on that, it will be differentiated number of bits or number of incrementing bits. Okay. In the same way, address only these will be changed, right? Only burst will be changed, size will be changed. Remaining all are same only. H trans will be same. Okay. And remaining what will change?
Ma'am, please explain with some pen.
Some.
With an example, if I have a 128 bits data, we'll have it says to one or two configuration. We can, if you take, it will be helpful.
Okay, wait. Suppose address is a 32-bit size. So you want to take address how much size?
Address can be 32. The consider if I want to send a 64-bit bits of data or like a 128 bits of data.
Okay. So if you want to take 64 bytes or 64 bits of data,
Means
suppose
I can send in one clock. The options are like I can send in per clock. I can send all the 128 bits, or I can send 64 into 2, or it will be 32 into 4, or like 16 into 8. That is the combination which will come into picture. Correct. How I want to send the data. Correct.
okay. So then H write data and write address H write address will be 64-bit data. Then you need to check with the transfer size. Transfer size need to match with the data width. Okay, suppose you are taking it as a double word. Word means 32-bit data. Size is how we will take means here. See here. 8-bit means byte size, H size 2-bit, and 32-bit means word, and 64 means double word, 128 means a 4-word line, 256 means 8-word line. Like that we will take. So here now 64-bit transfer. 64-bit transfer means how much? 011. So whenever you consider as a 64-bit transfer, your H size will be equal to 011. Based on this 011, remaining will be dependent. Suppose 64 bits means how much burst size. How can we calculate the burst size? Okay.
Ma'am, what is mean by burst? Is it like a same as the data width? If I want to send a
Wait,
64 bit.
wait. I didn't completed the concept yet.
Yeah.
You are
Okay.
asking the questions.
Sorry
I'm
to
just
interrupt. Sorry to interrupt.
I'm just in
Please
I'm
continue,
just
ma'am.
wait.
Yeah.
I'm just explaining the signals only. Okay, without explaining the concept, if you ask the questions, remaining people how they can understand. I'm just in introduction only.
Okay. Sorry, ma'am.
Just ask relevant questions. If you ask a relevant question, I can spend extra 1 hour also.
Sorry, ma'am.
So here, first of all, these are the signals for master side. Okay, size, burst. We will discuss one by one concept clearly. What is mean by size, what is mean by burst, and protect. You already know transfers. We have different transfer in the AHB protocol, and master lock. Master lock in the sense whenever there are multiple number of masters, we will lock one master, and remaining we will send with one master, remaining all will go to the lock state. Okay, and the write data you already know. Next, coming to the slave side. Slave side, same signals. Input side, same signals. Output side, ready out signal. What is mean by ready out signal? It's a response, transfer response. If the signal is getting correctly, then response signal will be either busy or okay response, error response, retry response, split response. Okay, in the same way, ready out also. And coming to H read data. Read data is coming out from the slave. Okay, so and input side, same signals. Coming to the AHB transfers, what are the different transfers available for AHB? Okay, first of all, transfer size. What is mean by transfer size? It totally depends on how much data, how much address you are considering. Okay, 32-bit means one transfer size is one value. 64-bit means transfer size will be different value, like that. Okay, and we have simple transfers. Simple transfers in the sense directly in single burst we can transfer the data. However, we are transferring in the APB protocol directly 8-bit data we can transfer. Like that locked transfer. Locked transfers in the sense same way. However, the multiple masters are using any one of the master will be having the data and passing the data, remaining all of locked. And burst operation. This is what very important. The burst operation where we can initiate the multiple number of transfers at a time. Next to weighted transfers. Okay, we will discuss one by one. First of all, type of transfers. What is mean by type of transfers? Whenever we are passing the signal, whenever we are transferring some data in APB protocol, how we transferred, if you remember the waveform, whatever P address is some value based on write operation, and P
P
select
select
should
P and
high and P
P
enable
enable.
should high, and whatever the
Yeah.
address is there and whatever the data we are passing at right side, based on the protect signal or based on the ready signal, whenever ready signal is high we can pass the data. So parallelly we need to check whether it's a write operation or read operation, and P select is high, enable is high, P ready should high, then only we can initiate the write transfer and read transfer in one go. Just within one transfer we can send 8-bit of data. Okay, so in the same way here we can't transfer in a one go. Okay, 8-bit transfer. Here we have different types of transfers like ideal. Ideal means 00. It indicate the new transfer. Okay, suppose 32-bit data is there. 32-bit data means whenever you are initiating the new transfers, it will start from the ideal. So if you see here, no data is required. No data transfer is required in ideal state and used when the master is granted the bus without performing the transfer, and the slave must provide a zero weight okay response. That means no data transfer is required. Just. And second one is a busy state. When will it indicate the busy state? Whenever master is busy but not transferring the data. In that case, it will indicate the busy state. Okay. Next to non-sequence. Non-sequence means 1, 0. 1, 0 means new address unrelated to the previous address. it start a burst transfer. That means it just indicate the new transfer. Okay, remember everyone, we will see the different types of transfers here. Okay, non-sequence means it indicate a new transfer and indicate the first transfer of a burst or a single transfer, whether you are sending just single transfer with 8-bit data or you are sending multiple burst of transfer, it just indicate the first transfer. And next, it controls the address and control signal or unrelated to the previous transfer. That means non-sequence means it doesn't follow the sequence. Suppose AHB protocol is a aligned transfer. Okay, we have two type of things here: aligned, unaligned. Okay, AXI protocol is an unaligned transfer. Unalignment means the addresses will not depend on previous address. Okay, but here aligned means total burst will be divided into the number of addresses. Okay, within the address it will be divided into the number of sequences we call. So that will be dependent on non-sequence or sequence. Non-sequence means before addresses it doesn't depend. Sequence means indicate a remaining transfer in a burst. It follow in the sequence manner. Okay, I will show you that what is it mean. See here. Type of transfers. H trans. It is indicating H trans. First one is a non-sequence. T0, T1, T2, T3, T4, T5. Okay, non-sequence means first of all burst transfer with the non-sequence only. Okay, after that every subsequent transfer in the burst will be the sequence. Okay, every time first one will be the non-sequence. And if it is a master is a busy state, it will indicate the busy state, or else it will go to the sequence state. Okay. And if you see here address, H address, the 32-1 address is divided into these parts, whether you are passing the 8-bit address or 4-bit or 16-bit, based on that these addresses will be divided. Okay, so first non-sequence, we are considering 0 into 20. Okay, next, suppose it's aligned, all are aligned only. Busy means 0 into 24. Okay, at this 24 state, it is in busy state. It should hold. Okay, until busy state is removed. So next should be sequence 0 into 24. Next sequence 0 into 28. Next sequence 0 into 2C. Like that it will follow 4-bit increment or 2-bit increment or 8-bit increment. It will follow accordingly. Okay, so here each one 4-bit increment. So 20, then 24, then 28, then 2C. Like that it is incrementing. And finally, what is the value? Suppose it is within the range 8-bit or 32-bit. It is following from 20 to 2C only. Okay, H right? These all just sampling at this point of time, just sampling. H burst. In H burst, we have two types. Okay, increment and wrap. First of all, burst means, what is mean by burst?
Group of
Burst
transfers.
means group of data, right?
Okay. So how the group of data will be transferred? Suppose if it is a 32-bit data, how the group of data will be transferred?
Eight bit of group at a time.
Okay. So
But that depends on the data bus, right?
Okay.
Transfer size. Depends on.
It depends on transfer size. Okay. Okay, see here. Suppose a burst. Burst means a group of multiple transfers done continuously without stopping. Okay. In APB protocol, we don't have the burst transfer concept. Directly we transferred 8-bit data, 8-bit data only maximum in APB protocol. So we have transferred just 8-bit data. But here We can transfer multiple data transfers at a time. Multiple in the sense 32-bit data is there. 32-bit data you can send multiple transfers at a time. Okay, so continuously we can send without stopping. We no need to wait until one transfer is completed, then only we need to initiate second transfer, then only we need to initiate third transfer. We no need to wait. Continuously we can transfer the data. Okay, so instead of sending one data at a time and waiting for the next command, burst means sending many data words one after another automatically. Okay, that's what burst means. So suppose if you send single transfer in APB protocol, then what happened? Single transfer is nothing but CPU will read only one data word. Okay, one data word at a time, whether it's a 16-bit data or 8-bit data. Okay, burst means CPU will read 4 or 8 or 16 or 32 data words back to back without reissuing the address of each word for each word. Okay, so that is what burst means. Only the starting address should be given and the burst will be indicated with whether increment type or wrap type. It automatically auto increment. Okay, so that all data transfer happens one after another, so that we can save the time and improve the performance. That's what HBurst. Okay, so more clearly if you want to see, here burst operation, see here 4, 8, 16 beat burst as well as undefined length burst. So burst size indicates the number of beats in the burst. Okay, so valid data transfer we can do like that, or else I will tell you how to calculate the burst size and all. So incrementing burst, wrapping burst, two types of burst will be there. Incrementing means what? Access sequentially locations with the address of each transfer in the burst, being an incrementing of previous address based on the previous one. It keep on incrementing one by one. Okay, based on how much incrementing size you are taking, +4 or +8, like that. Okay, an incremental burst can be any of the length, but it will set the limit. It should not cross 1 KB boundary. It will have the limit. Wrapping burst means if the start address of the transfer is not aligned to the number of bytes in a burst size, then the address of the transfers in the burst will wrap when the boundary is reached. That means same as increment only, but wrap means whenever the limit is reached, it will rotate again from there itself. But increment means again start from the zero address. From starting address, it will be started. That is what increment. Okay. So in burst, in AHB protocol, we have different types of burst transfers. Single means only one data will be transferred. Only one word will be read. Increment means continuous data transfers will be done. It keep on reading until master stops. Okay. In increment, we have different types like increment 4, that means 4 transfers. Increment 8, 8 transfers. Increment 16, 16 transfers. That means it read 4 words, read 8 words, 16 words, like that. Okay. Coming to the wrap. Wrap also same. Wrap 4, wrap 8, wrap 16. Okay, same as increment, but address wraps around the boundaries. Okay, around the boundary, just keep on rounding. So useful for mostly application wise in the cache memories, we use wrap only. Okay, so that is what the difference with burst, without burst. Okay, if without burst is there, suppose you are downloading some images. Just a second. Okay, see, suppose without burst means what? You are downloading some files in your from Google. Okay, so whenever it is downloading, first one photo or one PDF is downloaded and need to wait. Then only second download will be uh, initiated. Okay, then second PDF is downloaded. Then only it will go to the third one. Okay, but if you see sometimes if you click multiple download allow, if you allow multiple download at a time, that is what burst operation. That means all download will start at a time. PDF 1, PDF 2, PDF 3 continuously start at a time based on your internet speed or based on one by one, which is having less size, that will be going first, and then remaining one by one will be downloading, right? Multiple files at a time, no need to wait one after another. Okay, so which one will be faster? Obviously second option is faster, right? Multiple will be initiated at a time. So burst operation is also same. Okay, multiple transfers will initiate at a time. Clear everyone?
Ma'am, what is aligned, non-aligned?
I will explain. Till here clear?
Hello. Hello, madam. Actually, I have a doubt on a graph. Okay. Or suppose if it is reached to 32 bit, in increment, okay, if it is reached, okay, maximum size, it will again come to zero, right? Hello.
Okay. Okay.
But in graph, okay, if it is reached to maximum size of 32 bit, it will come in the reverse direction.
Okay.
Okay, reverse means
Wait, let me
like
complete
if
the
it will,
basics before I will explain you clearly. Wrap and increment. Okay, so what is mean by burst? Everyone clear, right? So we will discuss very clearly on incrementing and increment and wrap burst. Okay, so after that, next concept.
Just one question to follow up. This S trans, okay, we are closing this. So you said right. So the first transfer is non-sequence, right? So if let's say the next bus transaction, so in the first transfer of the bus, right? First would be the non-sequence every time, right? That's what you mentioned.
Yes,
So
non-sequent every
yeah,
time.
yeah. So let's say the second transfer begins of the same burst, right? So the in the second transfer also, the first would be the non-sequence again.
No, no. Once non-sequence, immediately sequence only. Not even busy also. But sometimes whenever the master or slave is in busy state, then it will indicate the busy. Or else immediately it goes to the sequence only. From
Okay.
non-sequence means what? Any one address. Within the address, any one location will be selected. Based on that selected signal, remaining all will be the sequence.
Okay. Okay. Basically, in a
That's
burst
what
transfer,
align.
however, whatever the size of the burst is, only the first transfer would be the non-sequence. Rest everything would be the sequence only, right?
Sequence. Yes.
Okay. Okay. Thank you.
Prasanti,
yeah,
on this
hello,
small doubt, like can't the first transfer be idle instead of
Ideal
non-sequence?
also, ideal also in some cases. Ideal, yeah, after ideal, it should follow non-sequence. After non-sequence, sequence.
Okay.
Ideal means nothing, no
Yeah.
transfers. Okay.
Hmm.
So obviously non-sequence we will prefer.
And ideal can come after that also, Like if some transfers got happened, now it is nothing is happening, then also it can come after.
After all sequences, it can come ideal state, but not middle of the
Mm.
non-sequence
Yes, yes.
sequences.
Yeah, okay, okay, thank you.
Okay, so
Hello,
next,
madam. Yeah,
tell.
like this non-sequence can come after a sequence also.
No. First non-sequence, then
It should be.
sequence only. Once
Okay.
sequence is
Then after
started, remaining all
uh,
should follow the sequence only.
sequence only. Okay, okay.
Yes.
Sequence only. Then non-sequence should not come.
Mm. Yes.
Okay.
Okay,
In
remaining
case we
H
have a
burst. H
new
burst is
transfer,
based on what?
like first we have non-sequence, then
Hmm.
sequences are followed. That is
Hmm.
only for the addresses like, for example, 20 to 2C. Say, suppose our next address is 30, it'll be again non-sequence, right?
It
Correct.
depends on how much increment you are considering. If you are considering 4-bit 4-bit burst, suppose here I'm considering 4-bit. So within the range it will continue, and next transfer will start from the non-sequence. If you consider 8-bit burst, total this address will be divided into number of 8 bits. Like that 16 means total divided into the 16. I will explain that.
Now, can you go to the previous slide? The definitions you wrote for the all 4 combinations. Can you show them?
Here.
See, non-sequence, please read out the twice. She already explained those. Let us give some time to her. She will continue. She will explain the basic transfer first, then we can ask a lot of questions. Sorry, ma'am.
See,
Sorry to
just indicate the first transfer only, and sequence will indicate the remaining all transfers. That is protocol rule, AHP protocol rule. Okay, so according to that H read data means once the write data is getting, the write should get low. Okay, whenever write is high, write operation, write is 0, read operation. So at this point of time, the read data will be getting. Okay, so here if you see H ready is low, whenever H ready is low, we cannot read the data. So that's why here it is waiting. Some more clock delay is there. I mean, the cycle delay is there here if you observe. So because of H ready signal. Okay, these are type of transfers we need to follow everywhere for all AHP transfer. That's why we are calling AHB as a aligned, AXI as a unaligned. I will show you both the differences also. You will get the point. Okay. Next, H size is fixed. Before some of you asked, right? So what the size, if you consider 8-bit size, then size should indicate 000. Half word means 001. Word means 010. 64-bit 011. Like that, the size will be fixed values. And then what are the different types of transfers? Okay, if you observe in AHP protocol, in APP protocol, we have 3 states: ideal, setup, and access. Okay, clearly I mentioned there, to transfer any data, at least 2 clock cycles are required. Within 2 clock cycles, we can transfer the data. If ready is high, we need to wait. It may take 3 clock cycles also. If ready is still high, 4 clock cycles. Okay, but at least 2 clock cycles are required, that are setup phase and setup phase and access phase. Okay, in the same way, in AHP protocol, we have 2 phases: address phase, data phase. Okay, so here address phase means a single cycle in which master drives the address and control signals. It indicates the direction, width of transfer, and if the transfer forms part of a burst, each address corresponds to the 1 byte of data. Okay, byte addressable. Data means data phase, address phase must be 1 cycle. Data phase, multiple cycles, because data side, if slave is not ready to accept, we need to wait. If it is a busy state, we need to wait. For that purpose, data phase will be one or more cycles. It is controlled by the H ready. As I shown here, it is controlled by the H ready signal. Okay. And this busy sequence, this only related to the address only, not related to data or read data or write data. Okay. Next. That is what write address phase and data phase. The slave samples and process the data. Address phase and data phase of different transactions are overlapped. Anyway, it's a pipeline. Okay, and that too burst transfers, right? Burst transfers means everything will done parallelly. Sometimes it is overlap. Okay. Whenever I told the downloading of files, whenever we download the file, sometimes all will overlap, right? Even sometimes small data, small size file will download first, and long size file will download after some time. So like that, address and data will transactions are overlapped, multiple number of transactions. Okay. Next, the difference between write transfers and read transfers. So if you see address phase, data phase. Okay. So in address phase, H ready, H address is 32-bit size. A, B. H write is high. H write is high in H address. So H write data. Data is write operation. H ready is high. So whenever H ready is high, we can write the data. In the same way, second one, H address. Initially write is low, and after some time write is high. So here write is low. We can't write the data in here because read data is high. So data is reading here after some time. Okay. So observe clearly here. Half cycle write data, half cycle read data. When we write the program, if you write perfectly according to the AHB rules, we will get same. Next.
Hello.
Yeah, tell.
Hello, hello. Hello, madam. Can you go to previous slide? Okay. In the above one, okay. Above signals, the write is high at first cycle. The second cycle it is going to higher. It is multiple.
Okay. In data phase, we get the data. In address phase, address should it just select the address. In data phase, we get the data. Here write is high, so here we get the write data.
Okay.
In the same way, read. Here read phase. I mean read side. In data phase, we can read the data.
Like in address phase, okay. The
Address
write,
phase
sorry.
just it will select
The
the
write,
read address.
Like I have one doubt. Okay, that H write signal is there, right? It is continuously high. It is high in first cycle and low in second cycle.
It is high in second cycle here. It is low to high. Low means it is right, and here in data phase it is high, right? So whenever it is high, immediately it will read the data. It is taking some delay here within the cycle reading the data.
Okay.
Ma'am, upper is one for write operation and lower one is for read operation, or what, ma'am? I can't explain.
Upper one is for write operation, lower one is for read operation.
Sorry to interrupt. The write and control signals only will check the condition at the address phase. So the write signal is only considered at the address phase. Based on the if write is high in the data phase, that the respective data will come right. So we have two phases. In the address phase, we have finalized the size, transfer, burst, wrap. We will give the control signals. In the data phase, so the write signal is not matter in the data phase. So that is the thing, right? In the address phase only, we have to select it is a write or read transfer. So we have two phases for do the transfers in HB. So in address phase, we have to finalize our control information, and in the data phase, it only append the data based on the right signal, on the size, on the increment, all these things. Is that correct? Because
Yes.
in the previous slide you mentioned, can you go to the previous slide?
Okay.
The previous slide. So here, if in the address phase, you have clearly mentioned a single cycle. Sorry. Here. Yeah. So here the definition is saying we will select all the width of the transfer and what is the control signal, write or read, all these things. In the data phase, it will check only for the slave HRD and the data will only happen. So in the data phase, if it is write is high, it doesn't matter for us, right? Because in address phase itself, we will enable the write based on the write transfer. We will make it low based on the read transfer.
Yes.
So here I have one question. Each address correspond to 1 byte data means to make the aligned address. For that we have to maintain this condition. The second point in the address phase. Each address correspond to 1 byte data. So minimum of 1 byte data it should. Can you explain that point?
Here 1 byte in the sense for even for 1 byte also we need to consider the which type of transfer it is, whether increment or wrap. Within the range, if you select a 4-bit increment, 4-bit increment is not possible actually for 1 byte of data. 2-bit increment we need to consider for 1 byte of data, so that it will increment 20, 22, 24, 28 like that within the 8-bit of data. Okay, so each address will be changing with respect to within the range from 20 to 28.
Understood. So before continuing further, can you
go beyond that?
Continuing further, can you explain quickly aligned and non-aligned? If you want to explain further, it is okay. But yeah, you can continue. Sure. Thank you. Continue.
Okay, so address phase means it just control the signals or set. Data phase means actual data is transferred in the data phase. So during the address, the master will send all the control information first of all. Okay, so what is that control information? H address, H trans, H size, H burst, even H write also. Okay, so based on the H write signal, if it is a 1, it will do the write operation. So master want the write data to the slave. 0 means read operation. So that decision is taken by the address phase by checking the H write signal. Okay. So in that case, what happens means, for example, master will set some address here, H address, suppose 1000000, suppose. Then H write is 1. Okay, H address is 8-bit. Suppose if we consider 1 byte of address, 1 byte of address means 8-bit, 100 or 1000000. Okay, so 80 will be the address. Okay, H write is 1. H size, what will be the H size? If you consider as a 8-bit, 000. If you consider as a 32-bit, 010, 64-bit 011. Okay, so the next in next clock cycle, master will send the H write data, so the data will be written accordingly. In the same way, whenever write or read is selected in address phase, the write signal will write. If it is 1, if it is a 0, read. So here write signal is 0, so read operation. Here in address phase, write signal is high, so write operation.
Hello.
Yeah.
Hello, madam. Go on. The read operation, okay? Okay. The data is changing the negative edge or positive edge?
Positive edge.
Okay.
Here
Okay,
data
that
is
black one.
with respect to the
Oh, yeah.
negative, with respect to the positive edge
Okay.
only, but still here data is not getting there. That's why it is shaded. If
Okay.
data is available, it will
Understood.
change from here only.
Okay. In which is actual read data, this data U or shared?
What?
Which is the actual data in the read
Mm.
operation. It's,
Mm.
the data is the actual data.
Yes.
Okay.
Okay. So next,
Okay.
with wait state. With wait state means H ready is low in write operation, and write operation whenever H ready is high, we can do the write. So here data phases are 2 cycles, 1 or more cycles, minimum 1 and more. And read side also, P ready signal is low for 2 clock cycles. So whenever P ready is high in third clock cycle, able to read the data. Okay, so with wait states. And multiple transfers, that means in the same diagram, just representing write and read transfers at a time. Okay. I will share this PPT also and even specification. I already told you at least one time read entire specification. Okay. For AHP protocol. There are nearly 104 pages. There are different types of transfers here. All are not important. Whatever important topics are there, I already mentioned in the PPT here. But at least one time, if you go entire specification, you will get more clarity. Okay. So this is what multiple transfers. Next, lock transfers. So what is meant by H master lock? How it is indicating the signal? See here, whenever H the non-sequence sequence ideal, that means still we are not getting the transfer here. If the master requires locked access, then it must also assert the H master lock signal. This signal indicates to any slave that the current transfer sequence is indivisible and must therefore be processed before any other transfers are processed. Okay, see, H master lock is just a signal used to lock the bus during the critical operations. Okay, so whenever H master lock is high here, it means the current master wants exclusive access to the bus. That means no other master should take the bus control until the lock is released. Okay, the current master only should access. That is what H master lock. So why it is needed means you already know we are using the multi master systems in SOC. There will be a CPU, DMA controller, DDR memory. These all are multiple masters, right? So sometimes a master need to perform multiple related operations without any interruption. So whenever CPU is transferring some data to memory and DMA controller also transferring the data to memory, there should be no interruption, right? So CPU is reading a value. It will modify and also it write back. Okay. In that case, if some other master take the bus in between, then data maybe it could be invalid, right? It become invalid. Okay. So for that safety purpose, whenever CPU is initiating the transfer, whether it is doing the write operation or read operation, it want all other master should lock. Okay. In that case, it will use this feature. Okay. In the same way, a DMA controller transferring multiple packets in one unit as one unit. Okay, in the same way, To prevent the bus switching during such critical operations, the master used the H master lock signal here. Okay, clear everyone?
Yeah.
So how it will work? How it will work means, suppose before starting, if I consider a SOC, here there is a CPU and some DMA controller and DDR memory and some low peripheral circuit, whatever. So before starting the critical transaction sets, H master is equal to 1. Okay, suppose it's a lock request. So here CPU, at CPU, H master lock is equal to 1. That means lock request. Okay, so during the locked sequence, master continuously uses the bus. Okay, so arbiter does not grant the bus to other masters. It doesn't grant to the other masters. Okay, so in the same way, after finishing, master set to the H master lock equal to 0. That means it is unlocking the bus. Remaining masters can parallelly access the bus. Based on the arbitration, remaining masters will get the bus. Okay, did you all understood? Whenever CPU is trying to communicate with all other slaves, it is locking this bus only to this CPU. Remaining all masters cannot access that bus. Okay, whenever CPU is releasing, that means is equal to 0, remaining DMA controller or DDR memory or any high-speed RAM can access this bus and make the communication between all the slaves within the SOC. That is what the reason. Okay, so without suppose what is the difference if you use without H master lock? Suppose CPU is reading, other master is writing, then what happens? The data becomes wrong. If you use master lock, whenever CPU is reading and after completion of that, it just modify and next IP will write the data. Okay, so that no other masters will interrupt. Clear everyone? H master is simply nothing but do not disturb me. CPU is telling that don't disturb me, I am busy. That is what H master lock. Any other doubts still here?
Oh, hello. Hello, madam. In the H master block, okay, we can do read operation. Hello.
Yeah, tell.
Yes, we can do.
What? Can you ask?
H master lock, okay. In the H master lock, we can do read operation.
Which operation?
Read operation.
What?
Read operation.
Read operation. Yeah,
Read
both
operation.
both write and read we can do. Both write and read can do. Only that master, whatever master it is selecting, H master log, only that can transfer.
Okay.
Remaining all should be like 0, no access with that master, with that bus. With that bus
Okay.
only they can't transfer. With remaining bus they can.
Okay.
Okay, so that is what master lock signal. Burst operation we already discussed, and we will discuss how to calculate also, and how the burst signal is encoding with respect to the, see here, burst 2 down to 0. 2 down to 0 means 3 bit, 0 means single, 001 means increment, 010 means wrap 4 bit wrapping burst. Before some of you asked, right, 8 bit means byte. So for byte, we use mostly 4-bit wrapping only. And 8-bit wrapping, 8-bit incrementing, 16-bit wrapping, 16-bit incrementing. First of all, what is mean by incrementing wrapping? We already seen here. What is the difference, right? So increment is nothing but in a burst, after each data transfer, the address is incrementing based on the size of the data. Okay, suppose H size, here H size field is, if you see here, H size is indicating 2 down to 0, 3-bit size. Okay, so if it is a 1 byte or 2 byte or 4 byte, based on the H size is changing as I shown before here. Okay, in the same way, the address keep in increasing sequentially without any boundary. That is what incrementing. Sorry, for incrementing there will be a boundary, 1 KB boundary. So in increment we have types 4, 8, 16. 4 means what? H size will be 4 bytes. It will be 00, 04, 08, 0C. Suppose if start address is, wait, I will explain. It totally depends on start address. How we will pick the start address? That totally depends on the system. Why? Because if you see here, we are writing the non-sequence first. Non-sequence means any address it will select. Okay. Based on the non-sequence, remaining all are sequences. Okay. Based on this, remaining all will be dependent. Okay. Like that, if we take start address as 10000. Okay. So you are considering increment 4. Increment 4. That means overall burst, whatever the transfer is there, that will be divided into the 4 addresses. Okay. 0, 0, 0, 4, 0, 8, 0, C. Like that. Okay. So the addresses increases by 4 bytes each time. So word size will be 4 bytes. No wrapping will be happened here. Okay. In the same way, wrap means what? Nothing but the addresses behave almost same like increment only. But wrap means it will wrap back whenever reaching the boundary of the burst length. Okay. So here it is reaching to 0C. Again, it will wrap back to 04 and then 08 and then 0C. I mean 00, 04, 08, 0C. But increment means it's still on incrementing next value. Okay, so that is what wrap. How does wrap work? Means suppose whenever once it reach the boundary address, the address wrap will loop around like this back to the lower address to the 00. Okay, so how can we calculate the wrapping boundary? Is nothing but number of bits into size of each bit. Okay, number of bits into size of each bit. So how can you calculate? Suppose 4 byte words. Wrap 4. We are considering wrap 4. Wrap 4 means burst will be the wrap 4. H size will be the 4 bytes. Then start address if you consider as 0100004 as a start address, then how can you calculate the wrap boundary? 4 bits into 4 bytes. That means 16 bytes totally. Total boundary size is 16 bytes. Okay. So boundary means 16 bytes block. Just create the 16 bytes block. So starting from aligned address. What is the aligned address starting? 1004. Okay. So it align the start address to the boundary. Okay, lower 4-bit of address is nothing but it ignore for the wrapping. So now here 1004 and 1008, 100C, and again 1000 wrap around here. Okay, after 0C, the next address will be 1000. Okay, so it will wrap within 1000 to 100F, like that. It's a fixed size. Okay, so whenever you need a load, like a fixed block of data, then you need to start some address at some address, but must stay within inside the boundary. Okay, so increment would have continuously outside the boundary, but wrap doesn't. Within the boundary it should have. Okay, that is what difference. Increment means sequential, wrap means wrap also sequential, but it rounded back to the same value, boundary value. Okay.
Initial value.
Mm?
It
Initial
wrapped back to initial value.
Mm. So see here for more clarity. Four-bit wrapping burst, wrap 4. Okay, so initial address whatever here it choose like 0 into 38 38. So next 0 into 3C. So overall this burst will be divided into 4. Okay, so 38 3C 3034 plus 4. Every address incrementing with a plus 4. Okay, that's what we are calling as a wrap 4. Okay, in the same way, increment. Increment means what? Its boundary is up to whatever the size you are taking. It will go keep on going to the till the size. Okay, suppose here we are taken 1K boundary size. It should not cross 1K boundary size. Okay, till 1K boundary size it can increment any address till any address within the uh, within the loop. So 38 3C 4044. After 3C 4044 keep on incrementing. But if you see wrap after 3C, it is again coming to 3034 within the loop. Okay, its starting address is 30, though it is starting address, but within that range selected non-sequence. So that's why we got 38 here. Okay, so 38 3C again going to the starting initial address 3034. But here in increment it is not going to initial state. It keep on incrementing 40 44 48 4C, like that it keep on incrementing. Okay, this is for increment 4. If you go with 8, wrap 8. So what is the starting address? 34 38 3C. So if you see whole transfer divided into the 8 sequence, 8 bursts. Okay, so 34 38 3C 20 24 28 2C. Again it is coming to 30. So this is what the range, it coming to 30. But if you go to increment, starting with a non-sequence 34 36 38 38 3C 3E 40 42C. After 3C moving to 3E. Okay, keep on incrementing. It is not again starting from 30. It keep on incrementing. Okay, so this is what aligned means in AHB. But in AXI, we don't have the align. Directly we transfer the address and data. Okay, so this is what undefined burst length, whether it's increment, whatever. So here non-sequence, sequence, non-sequence, again sequence, sequence, like that it is getting. Here non-sequence 20 is initial value. Sequence means 22. And non-sequence 5C, again sequence it is starting, so 5C after 60, again 64. So write operation, read operation. Just to take some time, okay. In the tomorrow session, we will discuss on remaining concepts, okay. Take time and just complete till here. It's 1.5 hours only, right? But okay, no problem. Tomorrow we'll see long session. If time is not sufficient, we will discuss in the weekdays one day. Okay. We need to complete AHB protocol this week, and next week AHB to APB bridge. Okay. And
Ma'am,
Okay.
next week for AHB to APB, I think okay, 2 sessions we will discuss clearly. Yeah, tell. Today complete everyone till
ma'am,
understand the
alignment,
concepts.
non-alignment.
Alignment, non-alignment, that's what I told. Here sequence 3, 4, 3, 6, 3, 8, 3. This is what alignment. Non-alignment means see here. We don't have any addresses here. We are not taking any aligned transfer. Even though it's a bus transfer, we have bus transfers in AXI also, but address is not aligned. Directly we are passing the data. Okay, that is what the difference here. If you see in waveform only, you can understand how the addresses are aligned here based on the increment and the wrap. And in AXI, we don't have that concept. Directly, we can send the data transaction.
Like, what is the advantage of non-alignment?
What?
What is the advantage of non-alignment concept?
Advantage of non-alignment is nothing but we no need to bother about whether it's a like what is the wrap, what is the increment, and how much we are considering. We no need to bother about that, right? So that is what the difference. Just directly we can transfer the data. Non-alignments is nothing but the data address is not perfectly matching with the data boundaries. That's why in AXI protocol we have non-aligned address that is allowed for the transfer. Okay, suppose here in AHP, that is what the limitation we have. Because of non-alignment, we don't have the perfection in the data transfer with respect to the these addresses.
Non-alignment means width is not fixed.
Width is fixed. Within the width only we need to transfer. Whether it's a 32-bit data or 4-bit, 8-bit data, whatever, width is fixed only. Normally 32-bit means here how it is getting, it will start from 00 to 04, 08, 0C and 0E, 0F. Based on that wrap or increment, it is going on. But there we don't take all those things. Okay.
I mean, non-alignment, how it's proceed?
Direct, however, before we did for APB protocol, right? Direct address, direct data in the same way. But here, the data and address will be divided into the channels. So if you see here, AW channel, that means for address right channel, within the right channel only, in that channel only, we can pass the address, and right channel here. Here we can pass the data, transfer the data, and B channel, we will get the response. Okay. Before in APB protocol, if you see, based on the write signal, if write is high, we did the write operation. If write is low, we did the read operation. Okay, but here we don't have any write or read. Both are done parallelly, nothing but full duplex communication. Okay. In a HP
Ma'am.
protocol, it won't support the non-aligned access, but in AXI it support only non-aligned. In AXI it is optional. Aligned transfers, if you want to take it, just optional. But here in AXI protocol, in AHP protocol, it is mandatory. Okay. Any other doubts? So just follow the specification. I will share the recorded session. Take time, because protocols we can't discuss very fast like that, right? You need to understand clearly. So take time, go to the signal descriptions, all these things we discussed, the block diagram, each signals and how the data are transferring. Take time and try to understand. Tomorrow we will discuss the remaining concept. Okay. For AHB protocol, we will discuss detailed RTL design and also UVM verification. Okay. And another thing, tomorrow morning we have a session at 11 o'clock, PCIe session. Okay. PCIe session is there. You can join everyone at 11 o'clock. Evening at 7 o'clock, AHB session. Okay.
Ma'am, AHB is full duplex.
AHB is not full duplex.
We can do one operation at a time, half duplex.
Yes, AXI is full duplex.
Okay, ma'am.
Okay, any other doubts? Sunny, okay, who are there? Ashwini, Karthik, Manoj, Nitin, Ranjit, Srija, Venkatesh, and Vinita. Any doubts?
Hello, madam. Can you show me this?
What?
This ASB slides. Can you show me this ASB slides?
Slides?
That's like these, like this document, ASB document. Which
Yeah,
you have
I'm
explained
sharing
it.
for all, right? From starting onwards. Did I miss anything to share?
No. Actually, yeah. If you share, okay, I will go to
Yeah,
once
I will
again.
share.
If I have any doubt, I will ask you.
Okay, sure. Okay. Okay, then that's it. Thank you all. Tomorrow morning, don't miss
Thank you.
at 11 o'clock.
Thank you. Yeah, thank you.